How are crystalline solids classified? They are classified on the basis of the nature of intermolecular forces. So we have 4 different types of crystalline solids. They are molecular, ionic, metallic and covalent or network solids. In molecular solids, the molecules are the constituent particles. You should know the constituent particles. So in molecular solids, which are the constituent particles? Molecules are the constituent particles. Now again, under molecular solids, you have 3 different types. They are non-polar molecular solids, polar molecular solids and hydrogen bonded molecular solids. Non-polar molecular solids. Here the constituent particles are molecules. Now what type of molecule can be taken as examples? Either non-polar molecules like hydrogen, chlorine, iodine or noble gas elements like helium or argon. Now why hydrogen is considered as a non-polar molecule? Because the covalent bond is between 2 similar atoms, between 2 hydrogen atoms. Now next we should know the type of interaction between the molecules. How are the molecules held together in non-polar molecular solids? The different molecules are held together by weak London forces or dispersion forces. Now coming to the properties, these solids are soft and they are poor conductors of electricity. Now what type of interaction is present in non-polar molecular solids? Weak London forces or dispersion forces. So due to which they have low melting point and they usually exist in liquid or gaseous state. Consider polar molecular solids. Here the constituent particles are molecules. But what type of molecules should be taken as examples here? Polar molecules like HCl or sulfur dioxide. In this case, how are the molecules held together? By dipole-dipole interactions. For example, consider hydrogen chloride. It is a non-polar molecule and it has a permanent dipole moment. So in polar molecular solids, the type of interaction will be dipole-dipole interactions. These solids are poor conductors of electricity. Now what about the melting point? The melting points of polar molecular solids are higher than those of the non-polar molecular solids. What is the reason? It is because dipole-dipole interactions are stronger compared to London forces. Hydrogen bonded molecular solids. Here you can take hydrogen fluoride and water as examples. How are the molecules held together in hydrogen bonded molecular solids? By strong hydrogen bonds. So that is the reason why they are known as hydrogen bonded molecular solids. They are poor conductors of electricity. Ionic solids are the next type of crystalline solids. In these solids, which are the constituent particles? Ions. How are these ions held together? By electrostatic, that is by strong electrostatic forces of attraction between the positively charged ions and the negatively charged ions. Can you give an example? Sodium chloride is an example. Can an ionic solid like sodium chloride conduct electricity in the solid state? No. Why? Because in the solid state, the ions are not free to move about. Now, if an ionic solid is in the molten state, will it conduct electricity? Yes. Why? Because the heat energy will be used to overcome the forces of attraction between the ions, and as a result, ions will be free to move. Therefore, in molten state, ionic solids will conduct electricity. Can an aqueous solution conduct electricity? Yes. Why? Because in an aqueous solution, the ions are free to move about and therefore an aqueous solution of an ionic solid will conduct electricity. Metallic solids. In metallic solids, the constituent particles are positively charged metal ions in a sea of free electrons. Now, what type of attractive forces are present in metallic solids? Metallic bonds. What is meant by metallic bond? It is the attractive force that exists between the positively charged metal ions and the sea of free electrons. Now, can you give few examples? You can give metals as examples: copper, iron, silver. Now, what are the properties? They are hard, they are malleable and ductile. They are also good conductors of heat and electricity. Why are they considered as good conductors of electricity? It is due to the availability of free and mobile electrons. They also have high melting points. They are lustrous. And what is it due to? They are lustrous because of the availability of free electrons. Let us now consider covalent or network solids. Here the constituent particles are atoms, and these atoms are held together by covalent bonds. But the covalent bonds are present throughout the crystal, so they are known as network solids. Diamond, silicon carbide, silicon dioxide, that is quartz, graphite, all are examples. In general, covalent solids are very hard and are poor conductors of electricity. They also have very high melting points. But graphite is soft and it is a good conductor of electricity. You know that in diamond, each carbon atom is bonded to 4 other carbon atoms. Therefore, free electrons are not available. Therefore, diamond or covalent solids cannot conduct electricity. Now consider graphite. In graphite, each carbon is bonded to only 3 other carbon atoms. The 4th valence electron of each carbon is free. Thus, free electrons are present between layers of hexagonal rings in graphite. Therefore, we say that graphite is a good conductor of electricity. Now, why is graphite soft? It is because the different layers can slide over one another. So, that is the reason why graphite is used as a lubricant. Diamond has a rigid 3-dimensional structure. In graphite, you can see hexagonal rings arranged in different layers.